All right, let's get started. Steve and Andrew, are you guys ready to rock and roll today?
Yes, we are.
Yes, sir.
Okay, awesome. Today we are talking the winter weather outlook. Everybody loves winter in some regards. Some people hate it, but after a really active tropical season, I think many of us are ready for a change, and we're looking forward to talk about this winter weather season and the forecast ahead. I'm really excited to introduce you to our panelists today, Steve Strum, the Vice President of Extended Forecast, Andrew Tutt, Weather Solutions Expert here at WDT. Guys, this winter looks quite interesting. We're excited to hear Steve's official forecast and Andrew to give us some ways where we can profit and protect against some of the threats from this winter. But I'm going to start off with something fun today. Steve and Andrew, question for both of you. What is your favorite winter activity?
Well, for me, I've always been a big fan of snow skiing, and so that's one thing I always get excited about every year is that opportunity to hit the slopes and find some good powder. And this year should provide a lot more of that, like last year across portions of the Rockies. So, getting ready to do that again this year.
Awesome. We like to call that in the broadcasting world a tease. Giving us a tease on that forecast. I like it. Andrew, what's your favorite winter weather activity? And by the way, Andrew is in Minneapolis, where the current temperature, the current wind chill rather, is 5 degrees. So the guy knows winter.
Yeah, it's a bit brutal up here. It's been a pretty cold start to November here. We had temperatures that were well above average. Third week of October, and it was like a switch flipped and it's gotten really cold. But to answer your question, one of my favorite activities, which you kind of have to embrace if you live up here in what we call the Northwoods, is ice fishing. So I got the ice auger ready to go and excited to get out this season. And the way things are trending is it could certainly be an early start to the season for us, as I've already seen some ice starting to kind of glaze over on some of the ponds just around the neighborhood.
Wow. That's incredible. Well, awesome. Thank you, guys. And again, today our focus is on winter weather and specifically the winter weather outlook. Here at WDT, we offer many different tools to both forecast and then react to weather threats that may impact your business. And so we're going to start off today to discuss our exclusive winter weather outlook. And to do that is Steve Strum, our Vice President of Extended Forecast. So Steve, I'll go ahead and turn this over to you to unveil your forecast for this year.
All right, well, thanks, Rennie. We're sitting here now just about 3 weeks away from the start of the winter season, at least from a weather standpoint. And so we're going to go ahead and take a look at all the variables that may be impacting the pattern this year and how things are looking to end up as we head into the months of December and beyond. So starting off, let's look, kind of the big picture pattern here looking globally. This plot here shows monthly average global temperatures, at least the anomalies in degrees C for the last 10 years or so. And you can see that huge upward spike we had a few years ago, and that was the big El Nino that we had 2 winters ago. And I've also highlighted in the red dots there the temperature anomalies for the months of September every year, because there's a lot of variability, between seasons, so it's kind of hard to tell the overall trends. But you can see over the last 2 years, the overall trend has generally been downward. And this September, which is the last month we have data for at this point, we have certainly seen a good decline from the last 2 years in terms of the average global temperature. And most of that is because all that heat that was produced by the El Nino 2 years ago has been gradually kind of, going to space and just, and basically it's been leaving the planet over time. And so we've had this general cooling of the overall weather system globally the last 2 years, and that trend should continue going forward for the next year or so. And so that, by itself does have some impact on at least reducing the threat for another extremely warm winter, since there is just a little bit less heat in the oceans and less heat in the atmosphere than there was the last couple of years as we head into this coming winter. Now, looking at the past recent winters here for the last decade and more, you can see here on the left-hand side, I have a plot of all those dots represent the average winter temperature on a population-weighted basis across the U.S. And I've highlighted the warmer than normal winters with red dots and the colder ones with blue dots. And I put trend lines on both of those sets of data. And you can see here what's kind of key is that there's not been any trend at all in the last 30, 40 years in the colder than normal winters. So when the winter is colder than normal, the last 5 years have been pretty much just as cold as the cold winters that we saw 10, 20, 30 years ago. There's not really been any trend there. However, there has been a strong warming trend in the warmer than normal winters. And the key there is that we've had this gradual warming of the ocean waters globally, Pacific especially, but also in the Gulf and the Atlantic Ocean. And so when we have a warm pattern during the winter season, typically we have a zonal flow or some flow, out of the Southwest, where we have a flow off the Pacific or the Gulf, or maybe even a little bit of the Atlantic Ocean. And so when the flow is off the oceans and those oceans are warmer, the air above those oceans is also warmer. And so the warm patterns that we have during the winter seasons in recent years have been warmer than they were, 10, 20 years ago. But when we have a flow pattern that brings cold air out of Canada, that cold air coming down is really just as intense as it was, 10, 20 years ago. So we've had this trend towards a divergence in the winter seasons where the warmer winters are getting warmer, the cold winters are pretty much staying put. And so we've had an increase in year-to-year variability. And this is important not for this winter just per se, but also going forward for the next several years and maybe the next several decades, really. If this trend does continue, we could see some dramatic year-to-year variation, which could really, produce some large swings in terms of energy demand and just, snowfall from year to year and that kind of thing. So the overall trend certainly has been favoring more extremes in recent years, and there's really no sign of that, ending going forward. Now, if we look at this year, what we have going on is we do have a developing weak La Nina in the Pacific Ocean. We had something similar last year. We have a little bit more of a La Nina-ish type pattern this year, though. We're kind of on the border right now of having a La Nina, and most climate models do forecast that La Nina to strengthen as we head through the next several months, not becoming a strong event, but just sort of staying in that weak La Nina-ish type range. However, some La Nina winters have been very warm, not very good for snowmen. Other years, really cold and snowy, very good for snowmen. So certainly, there's been a huge spread in La Nina winters historically. And so just having a La Nina by itself doesn't, by itself indicate you're going to have a warmer, cold winter across most of the U.S. So if we kind of separate them out, look at the difference in ocean patterns, again, there's not really been much change between the warm and the cold La Nina winters in terms of the actual intensity of the La Nina, but there have been some changes elsewhere. One noticeable change or difference between those warm and cold years is that in the area around Indonesia, which I have circled with the red circles, you can see that with the warm La Nina winters, typically we have somewhat warmer water in that area than we do when we have a colder La Nina winters, and also up towards Japan and in general, across the entire Pacific Basin. There's a little bit less warmth present than there is heading into the warmer La Nina winters. And this year, or last winter, we did have a lot of warm water around Indonesia, and that's really what tended to focus a lot of tropical convection, which we'll talk about here next, in that area. But this year, the water is cooler there, which should tend to help force a lot of that tropical convection a little bit farther east this year into an area that may be more conducive for helping to favor a rich trough pattern across North America that would be more favorable for bringing colder air down across a lot of the main population areas. Now, tropical convection basically tends to follow the warmest water. That's, clusters of thunderstorms, any kind of, large rain-producing areas that tend to form in those areas where you have all that warm water. And the plot here that shows the colors there is the actual observed current water temperatures across that part of the ocean basin. And those pink and purple areas represent the areas of warmest water. And you can see that the warmest water in those purple areas is located basically between Indonesia and the international date line, that dotted line going north and south on the map. And that kind of corresponds to that area on the map on the left there with the numbers of 5, 6, and 7. And those are phase regions that we talk about with the NJO, where we kind of assign a number to a different area, and so we can say, okay, the tropical convection is in that phase 5 or phase 6 or phase 7 region, and then we can kind of look at how that corresponds to patterns across North America and other areas. And typically, when tropical convection is in, say, regions 3, 4, and 5, like it was last winter, that tends to produce a scenario where you have a ridge in the western part of the Pacific, a trough in the Gulf of Alaska, and you tend to see a lot of warmth across a lot of the central and eastern portions of North America. But when that convection shifts eastward, the whole upper level pattern shifts eastward with it. And so you tend to see more ridging across the west coast of North America and a bigger trough in the eastern part of the country. And you get more cold air coming down from the Arctic into the central and eastern portions of North America. And so again, with that warm water being farther east than it was last year, we should see the tropical convection this winter be situated farther east. That should force the main ridge over the Pacific to be farther east than it was last winter, which will in turn push the main trough a little bit farther east as well. And so we should see more of the cold, instead of being focused across the Northwest like it was last winter, be focused farther east this coming winter. So now another factor in this winter is the quasi-biennial oscillation, or the QBO, which is an oscillation in upper level winds over the equatorial areas of the globe. And essentially every 2 years, they kind of flip back and forth from blowing from east to west. And that has an effect of generally modulating the overall intensity of the flow across the mid-latitudes as well. And so when the QBO is trending negative, that tends to sort of reduce the flow generally across the mid-latitude areas. You tend to see more of a high amplitude pattern, more ridge troughs, whereas when it's in a positive phase, we tend to see a stronger west to east flow typically during the winter season, which tends to bring more warmth from the Pacific eastward across the country. And so this year, with the QBO now negative and trending more negative, that tends to favor a generally colder than normal pattern across a lot of the central and eastern U.S. Last year, we had the QBO was positive. It was trending more positive into winter, which kind of corresponds to map D there on the slide. This year, we're actually sort of, in a pattern that is close to what we have for that map A composite on the slide. So everything with the QBO is much more favorable for cold across the central and the eastern U.S. this winter than it was the last 2 years when we had that positive QBO regime in place. Now, another factor always for the winter is the Arctic oscillation. That is a large-scale oscillation in the Arctic areas between high and low pressure there, which in general, when the Arctic oscillation is negative, we tend to see more ridging and more warmth kind of builds up towards the pole, which forces more cold air southward into the middle latitudes. And this year, there is some potential for a little bit better chance for negative AO than there has been the last couple of years. One aspect of that is the fact that we're heading towards another solar minimum. Typically, the map on the top right there shows the sunspot numbers by year, and each of those blue dots indicates a year where we had a negative Arctic oscillation pattern for the winter season. And this year, we're again heading towards solar minimum, and so we may have an increase in odds for negative AO just based on that. Now, not every year towards solar minimum has a negative AO. Many of them do, but not every year does. So we can't guarantee a negative AO just based on that. Another factor, though, is snow cover. The years that have had high levels of snow cover across Eurasia during the middle of the fall season have tended to see a negative AO more often during the winter season. This year, snow cover was above normal, not as much as last year, though. But we have had more snow cover this year in North America and more ice cover across the Arctic areas than last year. And so overall, certainly more snow cover allows more cold air to build and for that cold air to maintain its intensity as it comes southward, like we're seeing right now with this current cold air mass. And so in general, when you have more snow and ice, that is going to be more favorable for allowing more cold air to build during the course, especially of the early winter, when normally you don't always necessarily have a lot of those areas of Canada snow covered by this point in the year yet. So kind of putting all that together here, here's some composites of when you have a La Nina, when you have different phases of either a negative or a positive Arctic oscillation and either a negative or positive QBO. There's sort of 4 combinations you can have there. And you can see that when you have a positive Arctic oscillation and you have a QBO is positive and trending positive, which is likely not going to be the case this year since it's currently negative and trending more negative. But that composite favors a warm southern and eastern U.S. and a colder northwest, whereas when everything is negative, we tend to see much more widespread cold. Now, in all those scenarios, the northwestern U.S. tends to be colder than normal, and so confidence is fairly high that this year will again be fairly cool across that part of the country. And also, most of those scenarios show a colder than normal north central U.S., so that area as well has a higher probability of being cold this winter. But again, the East Coast only tends to be cold when all those 3 things are negative, and so the chances this winter there are a little bit less just based on historical trends of seeing cold along the East Coast and along the Gulf Coast. But again, things are kind of pointing towards that direction for this winter. So the odds are higher than average that will happen. But at this point, there's not enough confidence to guarantee that we'll see cold across the East Coast. So our current forecast for the winter season does favor a warmer than normal pattern on average along the East Coast and along the Gulf Coast, with the north central U.S. and the northwestern U.S. being colder than normal. However, we do expect that we are going to see several rounds of fairly intense cold happen periodically during the winter season across the southern and eastern U.S., but we may see just enough warm periods in between for the balance of the whole season to average a little bit warmer than normal. Either way, this winter should be far colder than what we saw last winter, which is that map on the right-hand side there. And so dramatic year-on-year differences. And again, we have a somewhat higher probability this winter of seeing widespread cold than widespread warmth. And so certainly the pattern is kind of, gradually trending in that direction. And the cold that we're seeing during this last week also kind of enhances the odds of that carrying over and repeating itself periodically through the winter season and producing, the same kind of cold pattern periodically during the months of December, January, and February. So overall, not quite, something like 2013 and 14, which featured extreme cold, but nonetheless a dramatic departure from the last two winters. Now looking at rainfall and snowfall, once again, the northwestern U.S. and the Midwest forecast to be wetter than normal, with cold across at least some of those areas. We should see above average snowfall across the interior Northwest, much of the northern Rockies again. The Great Lakes and parts of the Northeast could also be snowier than normal. The southern U.S. may average a little bit less snowier than average. However, a lot of years that have been similar to this year have featured some significant ice storms across portions of the plains and up towards the Ohio Valley and so forth. And so we'll have to watch for that potential for possibly a significant icing event at some point during this winter season across those areas from the southern plains up towards the Tennessee and Ohio valleys. So that could be a possible factor as well. So kind of just wrapping things up here, again, we have a pattern recently that's been quite cold related to an active MJO pattern, and that may repeat periodically throughout the winter season. So again, likely a lot of variability that may tend to kind of average out to still a little bit above normal along the East Coast, but overall, many areas across parts of the Midwest, the Northwest could average below normal this winter, and certainly much colder than what we saw the last two winters. Now, the odds of another extremely warm winter are quite a bit lower this year, and so we are fairly confident that we are going to see at least a more seasonal winter this year for many areas as opposed to the extreme warmth of the last 2 years. Also, though, we have had a tendency for during the last 10, 20 years for a lot of extreme winter events. So a lot of the winters have been very, extremely cold or extremely warm and not as much sort of in that, more seasonal range. So there is some risk that if we do see, cold develop this year, it could be colder than what we're currently indicating. Also, kind of sum things up in general on a population-weighted basis, looking at sort of an energy standpoint, with the East Coast and the Gulf Coast areas like Texas being still potentially a little bit above normal for the entire winter season, we may still see overall heating demand come in a little bit less than average, but again, certainly much higher than the last 2 years. So with that, I'll pass things on to Andrew, who can kind of show you some of the ways that WDT can help your business this winter season. Andrew?
Yeah, thanks, Stephen. Definitely an interesting forecast and quite a bit of a change from what we've seen during the last couple of years. I know last year up in Minneapolis, I was talking a little bit about ice fishing. That's one of my hobbies during the winter here in Minneapolis. And last February, temperatures were in the mid-50s, and I was out on the ice fishing, which actually sounds a little bit crazy. There's plenty of ice at the time, but that definitely looks like a scenario that appears a little unlikely going into the winter of 2017-18 here. Definitely looks a little bit cold, but we'll be interesting to see how things verify with Arctic oscillation and see if that's predominantly in a negative phase versus a positive phase. But thank you for sharing your thoughts, Stephen. Stephen does just a fantastic job with those forecasts. A little background. I'm a meteorologist myself, and one of my hobbies has been doing long-range forecasting. But since I've joined Weather Decision Technologies, it's almost not even necessary to do that because Stephen does such a good job of putting thought into these long-term forecasts. And speaking of these long-term forecasts, you can access those on our Frontier Weather website, which is available for subscription. So our customers tend to fall into a few different categories. There's Frontier Weather, WeatherOps Commander, and Skywise. So we're going to talk a little bit about each of these different categories here today. And I won't spend too much time on this. I know everyone's got a busy day. So we'll probably talk about 5-10 minutes over some of these different categories. But Frontier Weather, like we mentioned, you can see the seasonal forecast there. One of the great things is as good as Stephen is at making these forecasts, chances are a long-range forecast is going to update over time. And so if you want to see updates on the forecast, you can access that via Frontier Weather. If you want to see the forecast for what's going to happen in the spring or the summer, that's also available on the website. And then in addition to that, we just have a lot of different data sources on Frontier Weather. You can find historical weather information, forecast weather data. Basically, if there's a weather variable that you're looking for, whether it's historical or forecast, there's a good chance that's going to be available on Frontier Weather, and it's going to be available in a format that's really easy to use. For example, one of the common formats is a CSV file. So a lot of energy traders will take advantage of our Frontier Weather data sets. Now, WeatherOps Commander, that's kind of our flagship piece. The majority of our customers use WeatherOps Commander. It's an online portal. You can also view service from our smartphone and tablet app, and it's really aimed at risk mitigation and safety. So we'll talk a little bit more about some use cases for WeatherOps Commander coming up. And then there's Skywise. Skywise represents our GIS services, our analytics and APIs, and our map tiles. So for instance, with WeatherOps Commander, we have an interactive map, and there's a ton of different layers that you can access. Those are different map tiles that you could integrate into your website or whatever you might want to do. You can take those map tiles and use them. APIs, if you want current weather information, historical weather information, forecast information, you can access that. So a lot of people will use that data for analytics. And then also we have APIs that are extremely high resolution. For instance, there might be a farmer who wants to know how much it's going to rain in the northwest corner of their field versus the southeast corner of their field. That's what we can do with one of our APIs. And then we also do a lot of work with GIS as well. We're a partner with Esri. So if you use Esri products like ArcGIS Online and you want to integrate weather into that, that's really easy to do via some of the weather players that we have available. Like I mentioned, WeatherOps Commander is kind of our flagship product and service, so to speak. And so what I want to do is go through some different use cases of some different industries that rely on WeatherOps Commander for a day-to-day type of solution. One of those industries that I work with a lot is utilities. So for instance, one of the pain points for a utility is when they know weather is going to come in, they want to know exactly how that's going to affect their service territory. So for instance, in Florida, which sees these sea breeze triggered thunderstorms literally every day in the summer, they might want to know, hey, what portion of the service territory is most likely to see thunderstorms? And what they'll do is they will pre-place their crews in those areas, so when there is an outage, they can get the power back on as quick as possible. And so that's an example of how a utility would use WeatherOps Commander. We have all that forecast data. We make it really easy for, especially an area that covers a lot of ground. We make it really easy for them to understand, how's the northwest corner of the service territory going to be affected by weather versus the northeast or southwest or central, whatever it might be. In addition, utilities will also use our service for storm tracking. So like I mentioned, WeatherOps Commander has an interactive map. One of the great layers that we have available is high resolution radar data. Many of you on the webinar today, you may be familiar with our RadarScope app, which is available on Google Play and the Apple Store. Basically, what you can do is look at high resolution radar data for a specific site. And it's just going to update quicker than what you'll typically get with a North American radar data set that might update only once every 5 or 6 minutes. That's another way utilities will use it. And they also use our data as well. So similar to what we were talking about with Frontier Weather, they might want to receive data that helps them make a load forecast for purposes of purchasing and generation. So switching gears, that's utilities. Renewables, we also work with a lot of customers. Some of our customers include companies like Vestas and Avangrid. And so in renewables, they'll have wind farms. And if you think about a wind turbine, it's about 80 meters to 100 meters tall, depending on each specific turbine or manufacturer. And they're basically lightning rods. And so lightning is a major pain point for a wind farm. So what they'll do is we send them lightning alerts when lightning comes within a specific distance of their wind farm. And we can set that up so those lightning alerts go up by text or by email or push notification to our apps, and you can have that sent to as many people as you want. Another way renewables also uses our service is for our hub height wind forecast. So they might want to decide, hey, we want to do maintenance on one of these turbines, but we can only do maintenance if the wind speeds are going to be below a specific threshold. By being able to look at a forecast and see the hub height wind forecast, they'll know, yes, we can work on this day, or no, we can't. So they can use it for planning. And then also renewables tends to be really interested in archival lightning. So for instance, they might want to say, hey, I saw thunderstorms, they passed over the wind farm during the weekend. I want to know exactly where those lightning strikes occurred in correlation with my different wind turbines. So that way they can go back through and they can do blade inspections, and they can be really efficient with their time, because not all of the wind farm might have been affected by a cloud to ground lightning strike. So it kind of allows them to narrow that scope down and be a little bit more efficient. Retail, they also use our service. They want to make more efficient decisions about things as simple as store closures. So coming up this winter, let's say there's a nor'easter that comes through that's going to drop, 2 feet of snow on parts of New England. It's really good for retailers to know this in advance, so they can get that message out to their different district managers and site managers and make a good decision about whether or not they should keep a store open or keep a store closed. Obviously, that can translate into a lot of savings. If you close too early, you're losing money. Or if you keep the store open and you're staffing it and no one's coming in because there's a snowstorm, you're losing money there as well. So that's something that can definitely save revenue, or save money, I should say, for the retail sector. And then from an API standpoint, what they like to do as well is they like to use those APIs or use those data sets and say, hey, what's the weather been like in the past? And what they'll do is they'll take their sales data and they'll compare it to it. And they'll say, hey, I found this correlation. It turns out we should be putting these winter items on the shelves at this time rather than this time. Now, finally, one other sector that we do deal with a lot is the events industry, the sports industry. We work with different broadcast providers like ESPN, work with different sports teams like the Dallas Cowboys or the Washington Nationals. And so what they'll want to know is, what's the forecast going to be like? Do we need to adjust our scheduling? Especially when you talk about different colleges that just want to get a practice in, they'll look at our forecast, they'll jump on the phone with our team of meteorologists, and they'll say, hey, can we practice coming up this afternoon? If not, we need to make adjustments or maybe move practice indoors. So they use that a lot. The phone consultations with our meteorologists is really something that's used across all of these different industries. Our meteorologists did just a fantastic job, as an example, with Hurricane Irma and Hurricane Harvey. We did countless numbers of conference calls to help different customers out across these industries alone, in addition to some other industries as well. But getting back to the events industry, the sports industry, they also really take advantage of lightning proximity alerts, similar to what the renewables industry does as well. Obviously, pushing into a season where you don't see quite as many thunderstorms, obviously, as what you would see in the summer. But still, even in the winter, you can get lightning strikes, so something to consider there as well. So that's all I have for today. What I'll do next is I'm going to pass it back to Rennie. Thanks everyone for joining, and Rennie, go ahead and wrap things up.
All right, guys, thank you so much. We really appreciate both the forecast and the ways that WDT can help various customers in different industries. And so if you have questions or would like to see a demo of some of our products, we invite you to visit our website at wdtinc.com. That's wdtinc.com. There are a number of different options there to fill out a form, and we can have a representative contact you and talk about your business, some of the threats that you may have from weather, and show you some of the tools that can help out to help you both profit and be prepared when weather threatens your business and your industry. Again, thank you to Steve Strum and Andrew Tutt for taking us through this webinar, and we most certainly want to thank everybody that has attended and watched today. We know that your time is valuable, and we appreciate you joining us to hear about this upcoming winter. So if you do get some snow, enjoy it. According to the forecast here in Oklahoma, it might be less than normal, and we might get some ice. I'm not overly thrilled about that, but we will deal with it if it comes. Thanks again for joining us for this webinar, and we look forward to chatting with you soon.